Hello dear students, in this lesson we are going to talk about the angles. Let's first continue with the definition and how an angle looks like. So it's made up of two lines, arms, or you can say ray. Ray is more appropriate word to use here. So let us consider we have an initial ray and we wish to rotate it. So the way we started rotating it like this, we have turned it. So the amount of rotation took place in that case. That is actually the angle, or you can say that's how we measure the angle, or you can say the angle is a measurement how much we have rotated from initial ray to reach to the terminal ray. So we have two terminologies over here. One is called the initial ray and the other one we can consider to be the terminal ray, and the measurement by which we have rotated it, that's called the measurement of the angle. So this is my angle and it's represented generally using degrees, but there are other units too that we'll be discussing. Now try to understand how do we label an angle, how do we represent an angle. An angle can be found in various scenarios. We can just observe an angle anywhere, even our table corners, our notebooks, whatever, triangles, rectangles, everything is full of angles. Whenever we have two lines intersecting together, we get an angle. But theoretically, how do we represent them? There are many ways in which we can represent. Let me simply draw an angle, students. Suppose this is my one second. Let's say this is my initial ray and this is the terminal ray, and the one way is to just represent the letter using some small alphabet. Let's say angle A, B, C, D, any lowercase of English alphabet we can use. Or rather than using these alphabets, we could have also used some Greek letters like theta, alpha, beta, gamma. These are used in higher classes, but for now it's okay. Alpha, beta, gamma, psi, phi, these symbols are actually the Greek symbols, and that you can also use to represent an angle. But let's say you are given certain points on the line as well as on the vertex. Basically vertex itself is a point. Let's consider we have this angle, and obviously there is a vertex, the point where both the rays meet, that's called the vertex. Let's say this is O. Whenever we represent them in this way, we often use the uppercase of English alphabet. So let's say we have one ray OA, other ray we have as B. So the one way to represent this angle is we can even use this symbol of angle, a tiny angle symbol. We can directly say it's an angle O. Why? Because its vertex is just O. Alternatively, we could have said it's an angle AOB. Now make sure to keep the vertex in the middle. There is one more possible way, students. We can also call that as angle BOA. Means no matter we take A first or B first, but the condition is the vertex has to be in the middle. So O is the vertex, and you can notice that O is still there in both the cases. It lies in the middle. So it depends upon the situation. When you have some problem solving, you might use some symbols like 30 degree, 40 degree. Means angle can be given in certain degree measures, like if it's 30 degree, that's okay. You would say that's 30 degree, that's fine. But sometimes they might give the vertices like vertex as well as some points lying on those lines. Then you need to represent them using these alphabets. We'll discuss more examples and then that will be clear. For now, let's continue with types of angles. There exist different types of angles based on its measurement. So students, any angle which is less than 90 degree is said to be the acute angle. Now acute angle is something which measures less than 90 degree. A right angle is something which measures exactly 90 degree angle. Similarly, an obtuse angle is something which measures greater than 90 but less than 180 degree. Any angle, let's say for example, if I have an angle 70 degree, it's less than 90 degree, right? That's called an acute angle. If we have an angle which is greater than 90 degree, for example, let's say I draw an angle here which is a bit wider, and it's more wider than a right angle that you would consider, suppose 130 degree. So it's an obtuse angle. Why? Because it's greater than 90 degree. Now it may also possible that we have a straight line. It's not very clear from this diagram, but I can show you, students. We can still consider that is made up of two rays. Actually, it looks like there is only straight one single line, but actually we can consider, let's say we have one line like this. One moment, I can draw this ray. Say this is my one line, or you can say one ray, and other ray I can consider like this, going in the opposite direction. Just because they are exactly opposite, it looks like they're the part of a straight line, and yes, it's true. They lie on a straight line. However, there exists a vertex. You can notice here that both the rays are joined at this point. So no matter it's a straight line and it's called a straight angle, still that is an angle with two rays or two arms with one vertex in the middle. And this measures to 180 degree. This is exactly 180 degree. If you just wish to measure it, I'll let you know, students, how to measure the angles. But for now, this is 180 degree. Now, if an angle, let's say we have started from acute angle, then we have reached to right angle, then obtuse angle, then a straight angle. It may also possible that we further rotate the terminal side. This kind of angle is then said to be the reflex angle. Now, reflex angle is actually greater than 180 degree but less than 360 degree. And at the end, when you just complete one revolution, basically you revolve for one time and then you complete one revolution, and that's the 360 degree angle, or you can call it as full rotation. Full rotation simply means the point where you started, you came back on that. However, just because you started, let me just show you practically. Let's say this is your initial ray, and then I have started moving it. So this is acute, this is acute, 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 acute. And as soon as it became 90, now it's no longer an acute angle. It's a right angle now. Now beyond right angle, we have obtuse angle, obtuse, 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 obtuse. As soon as it became 180 degree, means a straight line, we can call that as a straight angle. Similarly, as we further turn it like this, now it became the reflex angle. And once we complete the one revolution like this, it now called a full rotation or a 360 degree angle. So this is how we can classify angles based on its measurements. I hope it's clear, students. So let's now continue with how exactly to draw an angle, or how to measure an angle. If it's given, you may also measure with the help of protractor. You can also construct angles with the help of compass, but right now we will be only focusing on protractor, how to use that. For that, I have another tool here. Let's say you have to measure an angle. First of all, let's suppose you are already given an angle like this, which has one initial ray or initial line and other is a terminal line. What you are supposed to do, students, see, this is how my protractor looks like. It has angles from 0 to 180 degrees from both the directions, in the clockwise direction as well as in the anti-clockwise direction. The very first thing you need to do, student, is align the vertex with this point. You can notice here this cross here. So this point you have to align together with the vertex of your angle. And you can also notice the initial ray of 0 degree. It also shows 180, but just look at if the angle is drawn in this anti-clockwise direction, align it to the same position of that line 0 degree. You align your initial line with that, and then you measure how much, where my terminal line coincides with. So now you can notice that it's almost 60, a bit more than 60, around 2 more than 60. It's about 62 degree. So we can now consider this angle to be 62 degree measures. That's the idea. How do we consider it? First of all, we keep the vertex aligned with this point of the protractor. Then also you have to align this initial ray with 0 degree. And then you just need to verify where my terminal ray aligns with which line. So it aligns with the 60 and a bit more, 2 points more than 60, which is 62 degree. So this is obviously an acute angle. Let's take another example. Let's say we have this, and this is how we got another angle. So you still do the same process. You can just go with your you just align the vertex together with the middle point of the protractor, then also align the initial ray with 0°, and it looks like the terminal ray matched to 40 or 140. So students, remember, because it's wider, you started from 0, so you consider 0, 10, 30, 40, 50, 90, 100, and then you reach to 140°. So this angle is particularly 140, not 40, because if it's 40, then it would have been acute angle, and you don't have the acute angle. Acute angle is narrower, obtuse angle is wider. So basically this angle is equal to 140°. So students, this is how we measure an angle. Now we'll try to understand how exactly to construct an angle. For example, we have to construct an angle of 60°. So how will you construct that? The simple idea is, you can first of all draw any line which is generally a horizontal line, but it depends, it's not necessary to keep it horizontal, but it looks good when you keep it as a horizontal line. You can even use a ruler to just draw. If there is any specific requirement of your line, you can use your ruler. Let's say you have to consider 5 cm. It doesn't matter though while constructing the angle, but suppose if it's asked to keep that particular length, so that's okay. Suppose this is 5 cm or 6 cm or whatever. You have constructed your initial line, and you have to draw an angle of 60°. That means you have to draw an acute angle, students. What you do then, again, you need to align, because that's where somewhere here only your vertex will lie, right? So just align the midpoint of your protractor together with the vertex and try to locate a 60° line on the protractor. So you can clearly see that this is where my 60 located. 60, 120 are coinciding. So no problem, just mark a point at 60 and then remove the protractor. Simply join the vertex together with that point. That's how we can draw that, and this angle is going to be 60°. See how easy it is. You can draw any angle up to 180° with the help of protractor. There is also a method, students, that we can use a compass. That's a bit lengthy process. In some other class we can discuss about that, but for now, using protractor, this is the way you can use a protractor and construct an angle of the desired measures. I hope you understood, students. So see you in the next video.